with your test being next class, you can hand stuff in today if you want, but I'm not going to be sending out any updates or anything, so you can hang on to stuff as well. You ready? There's either going to be a banked corner on your test, or there's going to be a conical pendulum on your test, because they're both almost an identical free body diagram. So if I say a banked corner has a radius of 75 meters and theta is 26 degrees, let's even draw it kind of this way as well. So I'll do the banked corner like that for some reason. Here's the car. Shut up, it works. We said we're going to do a free body diagram, so we still have gravity down, and we still have normal force up. And here, even though we had angles, we said because our circle that we were tracing out was horizontal, and because we want the net force to be horizontal, Victor, this is one-time components don't help us. Instead, we're going to add these two vectors together. Victor, how might I add these two vectors together? Draw them. And when I'm doing that, I always draw the easiest vector first, because that gives me my reference. So I'm going to draw mg first. And then I know to stop with the normal force right there, because I know that when I add those two together, the resultant, which isn't always the hypotenuse, it's just always from the tail of the first to the tip of the second, is a horizontal force, because we're moving in a circle. And we did some thinking, color, 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 color. We found that that was angle theta. So if we want to find this speed limit, I think I'm going to use opposite and adjacent. By the way, I mean, I could use that because I think the normal force is going to be the same as mg parallel. Mg parallel, of course it is. This would be mg I could use that, but why bother? They gave me the mass. They didn't give me the mass. Mr. Dueck, what's going to happen? Oh, wait a minute. Can little cars and big cars go on the same roads? I wonder if the masses will cancel. Let's find out. So I'm going to use these two, and it's going to be tangent. So I get this. Tan theta equals opposite over adjacent. I chose to get the FC by itself, and I got mg tan theta equals m. And then in my mind, I thought AC. Which AC am I going to use? The one with the period or the one with the speed in it? By the way, I guess I could also ask you how long it would take to go around the whole corner, except usually for a banked corner, you're not going in a circle, a full complete circle. You're usually doing like a 90 degree or something like that. So I guess that'd be a silly question to ask. I'll almost certainly ask you the speed. Or I'll give you the speed and ask you to find the radius, because in both of these, you end up with that. So if I asked you to find the radius, I would multiply the r to the top, and I would divide the g tan theta to the bottom on the other side. If I asked you to find, I asked you to find speed. Let's get the speed by itself. I'm going to get v squared equals ger tan theta. V is going to be the square root of ger tan theta. V is going to be the square root of 9.8. What did I say the radius was? 75. And tan, was it 26 degrees? Have you started trig in Math 12 yet? In Pre-Calc 12? Okay. So soon you'll have to get in the habit of making sure you're in degrees and not in radians. But for now, I'm still in degrees. So 9.8 times 75, tan 26, square root of that. You all get 18.9, is that right? Now, if you got that, I would give you 7 out of 7. Otherwise, I would probably go something like this. I would probably give you 1 mark for the vector triangle. I would give you 1 mark for that. That's 3. That's 4. That's 5. That's 6. and that's 7, something like that. Okay. Or you'll see a conical pendulum. Now, for the conical pendulum, there's a few more options. As far as I'm concerned, I can give you, or I can ask you for the period, or the speed, or the radius, or the, well, tension, it looks like, as well, for that matter. So this is a job for a free body diagram. I have mg down, I have tension up. I don't want to go components because my main net force is horizontal, so I'm quite happy with using the standard vertical and horizontal. I'm going to add these two together. Victor, how? Tip to tail, you say. So I get mg, I get tension, and when I combine those together, I get Fc. I notice that theta is between a vertical line and tension. Here's between a vertical line and tension. They gave me the mass. Now, if I'm looking at an FC, I bet you the M's will cancel, but the M's won't cancel for tension, and nor should they. You should be able to put a huge mass on there and break the rope, as opposed to putting a tiny mass on there and not having a problem. So for tension, they should not cancel. In the same way, up here, for normal force, it would not cancel. Normal force would not cancel the masses out, but we didn't care about that in this question. So I'm going to use opposite hypotenuse sine, yes? Sine of theta equals opposite. Sorry, it's not sine, it's cosine. Geez, Dueck, wow, no wonder you're all giving me that stunning silence there. I did catch it, no candy for all of you. It is cosine, yes? It's opposite, it's adjacent over hypotenuse. Wow, do I have sine on my mind? Cos theta equals mg over tension. So the tension is going to be mg divided by cos theta. It's going to be m 2.3, g 9.8, divided by the cosine of 18 degrees. (2.3 times 9.8, 9.8, Mr. Dueck, divided by cos of 18. You get 23.7? People nodding? And newtons. If you got that, 3 out of 3. Otherwise, I would probably give you 1 mark for the trig function, 1 mark for that, and 1 mark for the answer. If you use sine, I'll give you 2 out of 3, because sheepishly I'd have to sympathize with you because I was dumb and did the same thing. Find the centripetal speed. Now, I could also ask you to find the period, in which case, instead of using v squared over r, we would be using 4 pi squared r over t squared, right? Again, I'm going to be using some trig. This time, I'm going to use tangent. I could use my tension value, but as a good nerd, I would, if I can avoid using an answer to find an answer, I'm a good test writer, I'll try and do that. And I hope you noticed it's almost the same, it's even the same trig function, it's almost exactly the same mathematics as the banked corner. You get Fc over mg is tan theta. You're going to get mg tan theta equals mv squared over r. Here the m's cancel. And again, that's important. If they didn't cancel, then on the Music Express at Playland, on the musical swings, if you had kids of different masses, they would be going faster or slower. They'd be banging into each other from behind or smashing into each other from the front or something like that if you had people of different masses. The fact that, and also you'll notice when you're out there, theta is independent of mass as well. So an empty car and a full car swing out to the same angle theta. That's not quite true. A person sitting in the car has more air resistance than an empty car, and so you'll notice the empty cars go a few degrees higher because I'm ignoring air resistance. We want the centripetal speed. Okay. Oh, you know what? Same equation as before. V squared equals ger tan theta. So V is going to be the square root of ger tan theta. V is going to be the square root of, what did I say the radius was? 1.6. And then tan 18, was it 18 degrees? 9.8 times 1.6 times tan of 18 square root 2.26 meters per second. I would give you 4 out of 4 if you got that. Otherwise, 1 mark for that, 1 mark for that, 1 mark for that, and 1 mark for the answer. Then we really jumped a notch. Number 3, they want the normal force at location B. So I said, okay, this is a job for a free body diagram. I have gravity down and I have normal force down is what's pushing me in a circle. Both winners. So I said, okay, it's going to be normal force plus mg equals mv squared over r. Or it could be m4 pi squared r over t squared, but I had a sinking feeling I was probably going to be able to find speed. I want to get the normal force by itself. Tom, how do I get the normal force by itself? Yeah. So I did this. mv squared over r minus mg, and this is where I stopped. I said, well, I know m's not going to cancel, not for normal force. That's why little kids can handle rides easier than big kids. It's why you may find as you get older, suddenly rides that you used to like, you can't handle anymore. Gather ye rosebuds while you may, my angels. Enjoy the youth while you have it. But I don't know V. I don't know V. Any suggestions on how I can find my speed up there?
Could you find your initial speed going into the circle? Okay.
I could, but I think I can avoid doing that. I think I can do it in one step. Conservation of energy. Is there a change in height? Is there a change in speed? And especially, is there a yucky, curvy path? Oh yeah, I want a scalar approach. I don't want a vector approach here. So I'm going to let initial be right here and final be right there in my thinking. And I'm going to leave my normal equation, and I'm going to now go to some conservation of energy. So it's going to be kinetic initial plus potential initial equals kinetic final plus potential final. And sadly, that's not 0. And that's not 0. And that's not 0. Did I start at rest? Okay. Now, the other thing you could have done, and I had some people do this, what's big H? How high am I right here? And how high am I right here? Well, twice the radius, so 14. So I did have some kids let this be 0 and this height be 6. And if you did that, oh, awesome. Great. How many of you did that? No one. One of you. Okay, so I'll do it the way most of you did, the long, boring, schleppy way. Okay? So I'm going to get this. mgh initial equals a half mv final squared plus mgh final. The m's cancel. I want to get the v by itself. Actually, you know what? I'm going to get the v squared by itself. How many of you chose to multiply by 2 to clear out the 1/2 here? You, just you? The rest of you didn't, so I'll do it the schleppy way again. Ugh. Okay. So the GH initial minus the GH final, and then I divide by 0.5. That equals VF squared. I'm going to crunch that right now. VF squared is going to be the square root of 9.8 times 20 minus 9.8 times 14 divided by 0.5. No, because I'm doing the squared, Mr. Dueck. Thank you. I'd like to think I would have caught that, but maybe not. Thank you. Habit, 9.8 times 20. And by the way, if you square rooted it and then you just put it back in there and squared, you get the same answer. But let's save ourselves some time, especially since we missed the height of 6 and we missed the timesing by 2 to clear. Anyways, okay. Minus 9.8 times 14 divided by 0.5. Is it 117.6? And I guess that's technically meters squared per second squared because it's V squared. If you did throw units on there, I'm not going to be that fussy because I'm only partway through my work. I'm only fussy on units on your final answer. But that's going to go in there. Okay. So let's do this, Mr. Dueck, just so I can kind of separate things a little bit. The normal force is going to be M, 320. V squared, 117.6. I don't need the squared here. R, 7 minus 320 times 9.8. Plus, Mr. Dueck, minus. Do you get 2240? Yeah? If you got that, I would give you 6 out of 6. Otherwise, I would probably go something like this. 1 mark for that, 1 mark for that, 1 mark for that. That's 3. I would probably go 4 if I saw that. I would probably go 5 if I saw that. And 6 if I saw that number somewhere. Something like that. How many G's? Well, if I take this normal force and divide it by mg, that'll give me the acceleration. So if I take 2240 divided by 320 times 9.8, geez, brackets, Mr. Dueck. That's the acceleration, and if I divide that by 9.8, that's the number of G's, is it not? Or did I do that wrong? No, Mr. Dueck. That's the G's right there. Is it 0.7 of a G? Yes? Make that a G, Mr. Dueck. If I wanted the acceleration, I would just divide by the mass, and then I would divide by 9.8 to get the G's. So 0.71, what was it, 0.714? And the units for G's is actually just G's because it's newtons divided by newtons. There's no technical units. Okay? At the top, you'd feel very light in this ride. You would shriek and you would feel like you were about to fly out of or fall out of your chair. Now, you're not. You still actually have 0.7 G's of play, but we're just not used to feeling lighter than normal. That's what scares us the most in rides. Okay? C. What's the normal force at location A? Okay, at location A, I have gravity down. I have normal force up, and I know normal force is winning because that's towards the center. So my equation is going to be normal force minus mg equals mv squared over r. It's going to be normal force equals mv squared over r plus mg. Well, I know M, I know R, I know G. I'm going to find V again. How? Is there a change in height? Is there a change in speed? Is there a yucky curvy path? Hey, conservation of energy, G. So, K E initial plus P E initial equals K E final plus P E final. I was doing a deep dive last night on Wikipedia, and I did a search for vertical roller coaster loops. And I found the specs on the very, very first one, or one of the first ones that was built. And we calculated 6 G's if you barely made it. And of course, when they designed it, they didn't want people to barely make it over the top. They built what they thought was a huge safety margin in, so you were going really fast at the top. At the bottom, people were pulling 12 G's, which is a lot. That's enough to break bones if you're not careful. So for example, probably if you had your finger and in the middle of your finger you pushed down right there with 12 G's, that would probably snap your finger bone because your finger bone wasn't meant to take 12 G's from the side. It might be able to handle, probably could handle 12 G's from straight on because you lift up and you push on things all the time. Your bones are very strong in compression. Just not as strong in tension. I showed you the video of the one-fingered handstand from the Shaolin monks. Yeah, okay. Johnny's what? You might have been away. Anyways, 0 and 0, yes? And we end up with mgh initial equals a half mv final squared. Mass cancels, and I end up with v final squared equaling 2gh initial. And that's going to be 2 times 9.8 times 20. 2 times 9.8 times 20. 392. Ooh, oh, that's the squared. So that's going to go in there. I'm going to get a normal force of m. Was m 320? V squared is just 392 divided by r plus 320 times 9.8. This is not going to be a fun ride. Ooh, do you get 21,056? Is that right? Yes? Wow! 21,000. I'll write it as 21,100 newtons if I go to 3 sig figs, but if you said 21,056, that's okay. 6 marks, 6 out of 6 if you got that. Otherwise, again, I'd probably go 1 mark for that, 1 mark for that, 1 mark for that, 1 mark for conservation of energy, 1 if I saw that, and 1 if I saw that. How many G's is that going to be? G's is going to be the normal force divided by mg, and it was 21,056 divided by 320 times 9.8. $6.7. Jeez, 1 mark. Could you give yourself a lovely score at the top out of 28, please?